We have seen that the magnetic force on a moving charged particle looks like this by magnitude, where Q is the charge of the particle, V is the speed of the particle, B is the strength of the field, and sine theta is the angle between the velocity vector and the B field. And so this is a magnitude, but interestingly, this magnitude includes something that comes out of the vector nature of the velocity and the B field. Furthermore, if I'm going to make this into a vector, I can do it like that, where n hat, I'll write this down, n hat is a unit vector mutually perpendicular. I'm going to use the word orthogonal, I like it better. If you haven't encountered this word in a math class, in this class we can just talk about it as being perpendicular. That's just a physical consideration. It's a little bit more rigorous, but I'll leave that to your math instructors. N hat is a unit vector mutually orthogonal to V and B. That is, the velocity and the magnetic field form a plane necessarily because they're two vectors. Of course, if they're collinear, they won't, but then if they're collinear, the sine of theta is 0 anyway, and so this whole thing goes away. But if you have a non-zero angle between these two, they necessarily form a plane. The direction of the force is mutually orthogonal to that plane. We saw this in a previous video. We have a nice calculus way to describe this. Remember what math does. Math tries to describe the universe around us. There's an easy way to describe this. We can say that the magnetic force vector is equal to QV cross B. If you have not seen this before, this is one way in which we are able to multiply vectors. The dot product is one way. It's also called the scalar product because it gives us a scalar. This is the cross product, also called the vector product, because it gives us a vector. And as it turns out, this works for this situation. This is a good definition of the cross products I can come up with. By magnitude, it is the magnitude of the first vector times the magnitude of the second vector, I have that here, times the sine of the angle between them, right here. And then the vector nature is orthogonal to both of them. So there are different ways to calculate the cross product. Those are covered in separate videos, which will appear on this playlist after this video. But for the calculus-based courses that I teach, we're going to talk about the cross product. We typically don't explicitly evaluate a cross product. We typically deal with magnitudes and then get the directional information from what's called the right-hand rule. But you will need to know how to evaluate a cross product for this course. So watch the videos about cross product evaluation and expect to have to explicitly evaluate a cross product on some exam somewhere.